Okay, we'll talk about assignment 4 today. So here is the setting that we were talking about. So there is an arrival process AT, which goes through a join the shortest queue policy. And this policy sends the incoming packets to one of these two nodes. This is node 2, this is node 1, and the queue lengths are Q1T and Q2T. There is a servicing of these packets that these nodes do, and this is uniform 0 1, and this is uniform 0 1 2. The arrival process is uniform 0 1 2, and if you recall, the policy is basically going to assign if Q1 is less than Q2. I think I should just mention, let me remove this time axis here because I'm writing it for a specific value. This is A2, A1. And A1 equals to A with probability 1/2, and A2 equals to A with probability 1/2 if Q1 is equal to Q2. So this is the join the shortest queue policy. We are considering 3 cases in this assignment. So I'll talk about the 3 cases slightly later on, but for now I want to just tell you, like, the problem statement is we want to find the probability of dqi equals to A given q is equal to B. But there are many complexities with this particular conditional qi. There are lots of probability with this conditional measure. So let's talk a little bit about what all things we need to keep in mind. So the first thing is, if you look at the specific the value of dqit, it is basically so there is this maximum operator which takes what the current queue length is, what the arrival of the packet is, and the packets that are serviced in the past one time step, and 0. So basically, if your queue length is 1, if your arrival is 0, and if your S is equal to 2, then this term is going to be 0. The max of this particular thing, comma 0, which basically means this is -1. And then you are taking the max of -1 and 0. So this term is going to be 0. And then QIT is equal to 1. Right? So what we get is this DQIT. We are going to get it as -1. So that's something that we need to keep in mind. So this max thing is going to be 0. And then we subtract 1 from it and we get -1. So that's the important part that we need to keep in mind. And the second thing that we need to keep in mind is this way of sending incoming packets to different queues. So we are going to divide it by 3 cases. So let's look at what the 3 cases are. Case k equals to 1 if qi is less than qj and I is not equal to j. K equals to 2 Qi is equal to Qj. Qi is greater than Qj. And the way we are going to talk about P dqi equals to A given Qi equals to B, we are going to construct a matrix. Let's call it GB, no, Gi, and then B here. And this will have dq along the columns, potential values of dq along the columns, and case k equals to 1, case k equals to 2, and case k equals to 3 as rows. So we'll have 3 rows here. And the goal for today's lecture is to talk about how to fill in the blanks within these rows. So let's talk about that part. Let's assume that we are looking at, so for what is already given, I just want to make sure that you understand the part that is already given is G1 0 and G1 1 plus is given in assignment. So what we need to do is figure out the same thing for G2. So let's think about it. So let's consider the case of k equals to 0. No, k equals to 1. So 1 is very simple. We want to find out, let's say Q2 equals to, let's say 1. Case k equals to 1, Q2 equals to 1. And then I want to have anything else? No, I don't think anything else is needed. Okay. dq2 equals to minus 1. So under what conditions would I have dq2 equals to minus 1 when k is equal to 1, which means this one would imply q2 is shortest. So any incoming packet will be routed to the second node. So now we need to find out what are the possibilities, what are the combinations. So sub question here, what are the possible values of AT and S2T that yields dq2t equals to -1. I'm going to put t everywhere. So how do we solve this problem? So let me write down dq2t again here. This is max of q2t plus a2t minus s2t0 minus q2t. And I want this to be equal to -1. And I know that q2t is -1. So basically this amounts to saying that q2t is equal to 1. So with this negative sign, it's -1. I want this to be -1. So I want this max of q2t plus a2t minus s2t0 to be equal to 0. So in other words, I want this term to be either negative or 0. And that's because Q2 is the shortest, so all the arrival packets will come to A2T. So case K equals to 1 implies A2T equals to AT. So now let's look at what are the different combinations of AT and ST, which leads to this term being negative or zero. So let me remind you again, Q2T is equal to 1. So if my AT is equal to 0 and S2T equals to 1, then this would imply my Q1T plus 1, no, Q2T plus 1 equals to 0. Now AT equals to 0, S2T equals to 2. This would also imply Q2T plus 1 equals to 0. Are there any other combinations? If AT equals to 1 and S2T equals to 2, this would also imply Q2T plus 1 equals to 0. Are there any other options? Not really. If AT was 0, then S2T needs to be, yeah, I think we have covered all the cases here. So this would imply, so now what's the probability of each of these events? This event, this event, and this event. We need to add up all these three probabilities. So the probability of dq2 equals to -1, given that q2 equals to 1, is probability a equals to 0, s2 equals to 1, plus probability a equals to 0, s2 equals to 2, plus probability a equals to 1, s2 equals to 2. This is 1 over 3 cross 1 over 3. So the probability that a equals to 0 is 1 over 3. Probability that S2 is equal to 1 is 1 over 3. And these two events are independent. So that's why I have to multiply the two probabilities in order to get the joint probability of this event. And I'm going to do the same thing here. I'm going to do the same thing here. And I get 1 over 3. Okay, so that's how we compute this particular probability. Now let's look at the other case, which is case k equals to 2, which means with probability 1/2, A1T equals to AT, and with probability 1/2, A2T equals to AT. Let me pick the same number, Q1T equals to 1, and let's say DQ1T equals to -1. So once again, I need my Q2T. Oh, I need Q2 here. I need Q2T plus 1 to be equal to 0. Okay, so let's think about it. What if the incoming packets go to node 1, and what if the incoming packets go to node 2? Let's try to build up this table. So if AT, I'm going to remove the index T for now. So if A was equal to 2, S was equal to -1, so S is equal to 1, S2. Then my Q2 is equal to 0. If A was equal to, because remember this A is going to node 1, so let me just write A1 here for clarity. because A is equal to A1. 1, S2 equals to 1, Q2 equals to 0. I think I have more options. This is Q2 at the next time step. So this is, let me put plus here just to denote that this is at the next time step, not the current Q. I'll go through the same part again. Okay. Now we'll consider the case. What if S2 was equal to 0? In this case, there is already one packet in the queue. S2 is equal to 0. So none of the packets were serviced. So Q2 T plus 1 is going to be equal to 1. So that will not meet this criteria, which we had discovered in the previous slide. Now let's look at node 2. What if A equals to A2? So all the incoming packets are being sent to node 2. So A will be equal to A2. Excuse me. And then this is equal to 0. Then what do I need my S2 to be? I need it to be equal to 1, which would imply Q2 plus will be equal to 0. If A equals to A2 equals to 1, then I need my S2 to be equal to 2. And then this is going to be 0. And then A equals to A2 equals to 0. S2 equals to 2. Then the Q will be 0. Now, if there are two arrivals, then there can be, yeah, I think these are all the cases which would lead to Q2 plus equals to 0. Now, each of this event has probability. Let's think about it. So the probability of a specific A is 1 over 3. Probability of it being routed to one of the nodes is 1 over 2. And then the probability of picking a specific S is 1 over 3, because these are all uniformly distributed and independent of each other. So that's 1 over 18. And there are 9 such cases, 1, 2, 3, 4, 5, 6, 7, 8, 9. As a result of which, we have 9 probabilities to add. So just like we did this addition of these 3 probabilities here, we'll do the addition of these 9 probabilities here. So the probability of dq2 equals to -1 given q2 is equal to 1 is equals to 9 by 18 equals to 1 over 2. So that's how you would do the case when k is equal to 2. This is how you find out what the probability is going to look like. Now the case k equals to 3 is easier, because in k equals to 3, none of the arrival packets will come onto node 2. All the packets are going to go to node 1. And you will go through the same calculation and also compute exactly what the requirement on Q2 plus is. And based on that, you will figure out the A and S2 pair that will lead to that particular value of Q2 T plus 1. So this is how you compute the priority transition matrix. If you have any questions or doubts about your priority transition matrix, or if you want me to check whether your priority transition matrix is correct or not, you can send me an email via over the weekend, and I'll check my notes and see if they are the same as the priority transition matrix I have in my code. Then I'll let you know accordingly. Thank you so much. Bye.